first lesson of second semester. Now, originally I was going to go through the book, but because we're limited in time, we're going to follow our own pattern. So instead of doing 6.1, this is going to be lesson 1.1, okay? So in lesson 1.1, we're doing exponents and operations. So we're going to review how to use exponents and how they work when you're multiplying, adding, subtracting, things like that, okay? Let's start with exponents in general. Now, normally you have exponents like this. 64 to the second power means 64 times 64, right? But what if there is a root? So we're going to follow this as our pattern. The root can also be part of the exponent. The root, or in this case, this is a cube root, is the number that goes outside of the square root. And that number can be put underneath the exponent. So for example, here, we can do 64 to the second power over 3. So 2/3 is the exponent. And the top number, the numerator of the exponent, that is a regular exponent, but the denominator is the root, okay? So that's kind of the pattern we're going with. Another example, let's just say we had this. We had 9 cubed. Let's just say we had this, right? Well, there's no number out there. If there is no number in front of the root, we're going to treat that like a square root, okay? So treat it like a power of 2. So when you rewrite it using exponents, you would go like this, 3 over 2. So it's not about which number is bigger or smaller, it's about where they're positioned. So the regular exponent goes on top, the root goes on the bottom, okay? That's how you rewrite it. Now you can simplify this. So for example, if you want to take the square root of something, you can. So what is the square root of 9? You can do that first. So you can take the square root of 9, and the square root of 9 would be 3. Then you can take the regular exponent and say, okay, what's 3 to the third power? That would be 3 times 3 times 3. The answer would be 27. So then this, if you solve this, is 27. Another way to do that is you can take it to the third root first. So you can do 9 times 9 times 9. Then you can put that inside of the problem. So for example, let's just say we did that. We did 9 times 9 times 9. If we did 9 times 9 times 9, you would get 729. But if you take the square root of that, you would take that, the square root of it, and guess what you still get? 27. So there's two ways to go about it. You can do the numerator first, or you can take the square root first. It's totally up to you. You will end up with the same answer. If you're using a calculator, you can just do this. Pretty straightforward. But if you want to take the square root first, you can do that as well. Okay? All right. Next. What if you are combining roots? Sorry, not roots, exponents. What if we're doing this? So the shortcut for this, if you're going to multiply them, they need to have the same base. So they have to have the same big number. That's the base. If they have a different number, so if this was a 5 and this was a 4, you can't put it together. You can't. They both have to have the same big number. And when you do that, all you do is take your exponents and add them up. Now, if you're dividing, same rule. It has to have the same base, the same big number. But when you're dividing, you're actually going to subtract the top exponent minus the bottom exponent. Now, if you're multiplying, okay, that means you're taking it to the b power. When you have an exponent outside parentheses, this exponent is going to distribute. So that means that the x is also going to get a b. So you're going to have two exponents here, and the y will also get a b. Okay. Some people like to put a 1 in here. So you can put, okay, what's 1 times b? B. So you can actually multiply it. And you end up with these two different bases and different exponents. And these will not combine because the bases are different. The big numbers are different. Okay, so let's do some real examples now, just to show you how that works. So here, if we do 8 times 8, 8 to the 1/3 times 8 to the 1/3. Well, they have the same base. So what we do is we write that base and we take the 1/3 and the 1/3 and we add them up. If you add it up, you get 8 to the 2/3. Okay, now this is where you have a choice. You can take the root or you can square it first. It's totally up to you. So uh, if you want to, we can just square it. So we can do this. We can do cube root 8 squared. This would be 64. And then in your calculator, if you take the cube root, you would get cube root of this would be, I want to say 4. Cube root is 4. And that's your answer. The answer is 4. Here, since we are now dividing in a fraction, they have the same base, 2/3 minus 1/3, and you're subtracting. So your base stays the same. 2/3 minus 1/3 is 1/3. So now you're just taking the cube root of 8. Now you don't have to put a 1 there. You don't have to put it. You can just do cube root of 8. And the cube root of 8 is 2. And that's our answer here. That's the answer there. Okay, here you have a cube root and you have 2 numbers inside. So the 1/3, this cube root is going to distribute. So you're going to get 8 to the 1/3. And then with the 2, you're going to multiply 2 times 1/3. So you end up with this. 8 1/3 and x 2/3. Okay, and you can do them separately. So you can take the root of 8, the cube root of 8, and you could take the cube root of x squared. This would be 2, and you can't actually do anything with x, so you can either leave it like this or you can just leave it as a fraction. You can leave it written like this. That's actually probably the better answer. Just, you can't do anything with that, so you just leave it like that. Okay?